Today I'm going to talk about some of the issues around mostly sort of mobile devices when they attach to the network and sort of information that they let slip when they do so. Basically talking about initially sort of, well, mostly about the use of static MAC addresses really, and how they sort of leak information and they're kind of being abused or used depending on how you look at it. And then I'm going to talk a little bit about the other protocols slightly higher up the stack that also end up being influenced by the use of these static MAC addresses, or basically use these static MAC addresses. And then talk about some experiments that have been done at the IETF recently, giving it a go with randomizing MAC addresses on machines and seeing what effect that has and how machines behave. And then looking at what the IETF and the IEEE are starting to do in this area, and then just what we're doing next. So internet privacy is a bit of a sort of big buzzword around, with old Edward Snowden sort of throwing the dirt on the NSA and our GCHQ and the rest of them. Essentially how much tracking is going on, but I guess it's kind of, people probably were aware of that to a certain point. But anyway, it's not necessarily that those type of organizations a lot of people are concerned about. You don't necessarily want your device in your pocket to be tracked by anyone if it's not sort of under your control. It's fair enough if you kind of say, yes, I want to be tracked, but with a MAC address you don't get that option. We're basically, as I said, focusing on layer 2, layer 3 aspects, and then looking at some randomization stuff. So the IEEE, basically the MAC address is standardized by the IEEE and ISO, and it was originally developed by Xerox, and it's used in Wi-Fi, Ethernet, Bluetooth, 802.15.4, things like that. Basically a lot of the networking technologies today, still mostly using this EUI 48 format, but there is also the 64 format out there as well, and it's allocated by the IEEE registration authority in a bunch of different formats now. It used to just be broken down in half, and then it would be the company and then the sort of host identifier bit. But now there's a bunch of different approaches. MAL, which is sort of a large allocation, medium and small, MAS, and MAM. And then there are sort of non-unique address allocations as well, using this company ID, which is essentially a little bit similar to the middle one. So essentially the MAC address is a static, globally unique identifier, and it's pretty much associated with the devices for its lifetime. So this is the sort of this is the basic structure of the of this typical organization you get, where you have the OUI bit, which is the bit that identifies the manufacturer, and then this is then sort of this rotates, and they, in theory, all of the bits of hardware have different numbers, and then you've got in this very first byte of the OUI, you've then got two flag bits. One is sort of unicast, multicast, but the other one is this this local admin bit, as it's called. So typically it's set to 0 with most sort of global allocations to companies, but one can set this bit to 1, and then it's then indicates that it's a local administrated address, and then potentially you can set it to whatever you like. So that's typically what's being done in our experiments, and also in the developments that have come in some new operating systems. So the privacy issues. So as I said, obviously the MAC address is attached to the device, and so for Wi-Fi, the probes in traffic carry the MAC address on it as the source address, so you can then use that to track the device, whether it's attached to a network or not. And also in the case of some devices, they also do these directed Wi-Fi probes that then contain SSIDs of networks that the device is already attached to, so it's further information that's sort of leaked at rather an early stage of not even attaching to the network, but just attempting to. This information is being used by a bunch of organizations already. I mean, advertisers are often get in there first to sort of work out how one can track consumers, and then there are the sort of retail analytics places, and there was, I mean, you probably read about these things, trackers in sort of dustbins around central London for a while. There were these smart dustbins that had Wi-Fi tracking kit in them, and then they were then selling on the information, and then obviously all the security agencies sort of use it for, say, tracking certain individuals, or as in addition to, say, trying to track phones and things. And there've been various research papers demonstrating you can use this sort of combination of information, seeing the probes and then seeing the directed probes, and you can construct sort of social graphs looking at collecting this information up, and then you can find out who's talking to who. And then there's also work that you can, well, I've been working on a bit actually in a kind of carrot and stick type of way, in that you can take CCTV footage, and then you can then monitor the Wi-Fi, and you can actually then sort of correlate the two. I mean, it's possible. It's been done in theory, but in practice, we've been demonstrating that it's possible. In some work that we've been doing, just demonstrating really that it's not such a great idea to have these static IDs just floating around attached to your devices. So the implications at the higher level, there are a whole bunch of protocols, but typically there are sort of early ones. There's one called DNA, Detection of Network Attachment, that I'll talk about in the next slide. And then there's the other ones, MDNS and Whisper. They're sort of not so closely tied to the MAC address, but there are potentially things that can be gleaned from those announcements and so on, and interactions. With IPv6, you've got the auto-configured MAC addresses, which are potentially allow layer 2 addresses to become available or viewable at layer 3. But this has been tackled a bit by the privacy extensions RFC, and then the opaque IDs one. The privacy extensions one means that the host bit of the address gets changed, and that's actually the default on a lot of operating systems, has been for some time. Things like Windows and iOS have been doing that for a while as default. And then sort of MAC addresses have been mapped so that then they can then be used as for Wi-Fi based positioning. But people are probably aware of that. This protocol DNA, RFC 4436, I had a little poke around into this, and basically what it does is it's a sort of speed up protocol for DHCP. It was standardized by, well, in the IETF, and Apple were the sort of main driver, although there were others on it, and it's implemented in all Apple products in iOS, OS X, and it is also implemented on Google Chrome, on their OS that runs there, and essentially it caches the MAC addresses of APs that it's attached to, and when you're then roaming to other Wi-Fi APs, it then sort of proactively tests these MACs to see whether they're there, and if they're there, then it says, "Aha, I'm on that network, and I'll attach a bit more quickly." But there is a bit of a privacy issue in that the previous MACs can potentially reveal where and when your device has been. So you often get a trade-off with these types of protocols. So Apple came up with a kind of fix, and so there was CVE 2012 3725, which basically someone said, this is a kind of a bug, really, and why don't you try and not send MAC addresses all the time from every network. So what they then did was they said they were going to filter the MAC addresses, these sort of tests, based on the SSID. So when you come back to the same SSID, then you'd then just try the same MAC. So then you wouldn't be sort of spilling the beans from one network to another network. But the problem is that although they wrote all the code to do all this in iOS and OS X, they unfortunately there was a bug in the code which was discovered by myself last year in March. So sort of 3 years they'd apparently fixed a bug, but unfortunately they hadn't tested it properly, which is a bit disappointing. The sort of the hint was basically it worked in a kind of verbose debug mode, which you could basically, it's a runtime verbose mode. If you flip the bootp daemon into that mode, then it would all work. It would spill out the log messages saying I'm doing the right thing. To put it into consumer mode, it wasn't working. So it was a bit of an indictment on Apple's sort of test process, to be quite honest. So I reported it in March. It finally got fixed in August of last year in 841, and they did actually fix it that time, although they still actually goofed up the description of the fix, unfortunately. But it is essentially fixed, so now it does only send out MAC addresses that is discovered on one SSID, only to that SSID, not to all the others. So, running a bit tight here. Yes, privacy mechanisms. Well, basically, I'll try and speed up a little bit. Essentially, randomizing the MAC addresses and on devices. So devices can't necessarily be tracked from one network to another network. So if you find someone in one place, you can't say, "Aha, they're there." That's essentially the sort of main approach. There are other approaches. There are in Bluetooth actually. They have MAC randomization schemes which are put into Bluetooth Smart. They're part of the standard, and they essentially have a number of different approaches. That it's a bit like this cryptographic addressing in IPv6, where essentially you have a key that can allow you to sort of unlock the randomization sequence. If you don't know the key, then it looks like a random address. There are other approaches where you could copy MACs, and then there are other approaches which are more sophisticated, where you basically have to modify some of the protocols, which basically makes it rather difficult to deploy on a wide scale. So as I said, Bluetooth has a couple of, it's got the static randomized addresses, which you basically change it every time you power up the device, or you've got these private random addresses, either resolvable, where you have a key, or non-resolvable, where you just don't have a key and they're just random. Now, in iOS 8 and 9, they introduced randomization of MAC addresses at the probe packet level. So when you're probing for a Wi-Fi network, they randomize the MAC addresses, so you can't sort of use those for tracking people. And in Windows 10, they've actually gone a little bit further, believe it or not. And Windows 10 Mobile, they have, although the thing is this is optionally available, so it's not actually switched on as default like it is in iOS 8 and 9, but you can have probed, randomized MAC address on the probe packets and on the data packets. But then what happens is if you associate with an SSID, then or a Wi-Fi network, it will then keep that MAC address on the one that it's one that you've associated with, so it won't keep changing it. So if you've got like sort of keying material stored in your laptop, it doesn't sort of mess that up. Android, there's some things, but Google is sort of suspiciously quiet on this area. So just quickly on these trials that we did, essentially at the IETF, we basically just a sort of fairly simple change. If you're on a new network, you change your MAC. You change your MAC address, and if you're not on a network, you just periodically change your MAC address. So we did it. IETF 91 was the sort of first trial, and we had a special SSID for that, and then people joined. And then IETF 92, as a result of some of the tests we did there, it was then expanded. There was no special SSID in IETF 92, and it was a larger trial because basically in the first one we found that there weren't any adverse impacts on the equipment and so on. So there was a bunch of scripts that we developed for the different operating systems. And this is joint work with these guys, Carlos and Joan. So this is in the first trial. So there's only like 12. It's not there weren't actually a huge number of people who signed up to the trial. But what this is these are the IP addresses that were on the network, and this is the number of how many different random MAC addresses were assigned. So what we did to sort of help us sort of follow the trial through, they set a client ID, DHCP client ID, that then allowed us to essentially say that each one of these bars essentially would represent one person, but we could then see that their MAC address was changing. So obviously they wouldn't have to do that in a real situation, but it allowed us to sort of see the behaviors. So this character here must have been online all the time, and he went through a lot of different MAC addresses, and these guys just were fairly small. So then we looked at, so then in 92 we got like double the number of participants there, and we're just getting higher adoption, and there weren't any sort of inverse impacts on the DHCP servers and so on. So it's basically continuing now at the IETF. So IETF Privacy work, well, there's a sort of bunch of stuff going on at the IETF. I mean, there's the kind of classic original RFC 1984, which is kind of complaining about what's resurfacing right now, sort of key escrow, and maybe we can just read the good guys sort of communications and not the bad, and sorry, the other way around, read the bad guys communications and not the good guys, but as we know, that's rather an awkward problem to solve. You basically have to keep everyone secure. So there's been a number of sort of RFCs basically going through. So there's some stuff about privacy considerations, and then just more recently in DHC working group, they've been looking at privacy implications of DHCP v4 the fields, and they're doing a sort of analysis of them. And then there's an anonymity profile for DHCP clients. So in principle, if you use this profile, if you reattach the networks, you can't necessarily be connected from one attachment to the next attachment. And there's a privacy enhanced RTP conferencing working group. IEEE, well, this is something I was more closely involved in. There was a plenary meeting in 2014 on pervasive surveillance of the internet and designing privacy into internet protocols. So one presentation of mine was in there, essentially about MAC address privacy. And then this resulted in the formation of the 802 Privacy Recommendation Study Group. And then at the end of last year, IEEE project was formed, and now we're working on some IEEE privacy recommendations for the protocols that are coming out of the IEEE. And then these are just some of the sort of related publications. So this one here, I did it. There was a W3C IAB sort of IETF workshop paper that then led to the IEEE work, and then this is the paper that was detailing the IETF trials, essentially. So essentially, it looks like it's not a bad idea to sort of try to move away from MAC addresses, although static MAC addresses. Although obviously, I think in managed environments, one has to have the option of having them not change all the time, or having ways of tracking them. And there are sort of clearly some big outfits, whatever, Apple and Microsoft are starting to provide these features in products. So there's a clear sort of recognition that it's probably a good thing. And I'm now working on a project here, 5G Ensure project, which is to do with security and privacy in 5G. So I'm sort of looking at similar issues, identifier leakage and information leakage in 5G protocols. So sort of more towards 3GPP standardization. But 5G, the mobile networks are becoming more and more IP. So the sort of work in IETF is closely kind of, it's impacting a lot of this anyway. There are a lot of IETF protocols running behind the scenes now on the mobile networks. So that's a lot. So if anyone has any questions, it's got to speed it up towards the end a bit.
Hello. Hi. Will Hargrave. I think my affiliation here is probably CCC Events Network Operations Centre. We work on some large networks where we like to ensure privacy for our users. I was interested to see your experiments, and you now say you've deployed this at IETF meetings. Presumably you still need to have the people that would like their privacy to be enhanced to run scripts on their devices? And how does that work with mobile devices that aren't rooted and so on? What's the current state of the nation there, I guess?
Yeah, well, it's tricky. As I was saying, in iOS now you've got randomized probes on actually, I didn't mention it, but it's on the newer hardware, so you don't get it on. So on my sort of ancient iPhone 4S or 4, it doesn't do, although it will run iOS 9, it won't randomize the MAC addresses. But I think it's the 5S onwards, because I think it's offloaded into the drivers, the randomization stuff, so it can be done at low power. So when the sort of system is running in low power state. And in Windows 10 Mobile, you can basically flip on this randomization feature, as far as I'm aware. And in Windows 10 Laptop Edition, iOS El Capitan doesn't appear to do a Mac randomization yet, so it's a little bit behind the curve there. Google seem to be somewhat reluctant in this space. And you essentially need to sort of root the device to run a few of these things, and it's also a bit hardware driver dependent. But I mean, the Android sort of landscape is a lot more of a kind of wild west. Typically you kind of drop an Android version onto a piece of hardware, and then they just sort of leave it and go buy a new one if you want an upgrade most of the time, unless you're buying the Google hardware. But there are some scripts that will run on Android, but it's not as reliable.
Do you think we'll see this shipping more ubiquitously on lots of OSs, or it seems that Microsoft have gone in for it, but then maybe the people that get more ad revenue have decided not to improve the privacy of their users?
Yeah. Well, it's the thing is, I don't know if there's a massive loss in terms of that, because typically a lot of the retail analytics places, they'll offer you free Wi-Fi, and if you connect to the free Wi-Fi, then you're kind of consenting to being tracked, and it's fair enough. I mean, if you have the choice, I guess. With a MAC address, you don't have a choice. You can't switch it off. So if you can decide to join their free Wi-Fi, then
actually, the sort of converse is true. As a network operator, we spend a lot of time trying to throw away data and making equipment throw away data, because it's like, oh, hello, I saw this Mac, I recorded this for the rest of eternity, for posterity for you. And that's, we find, is actually becomes a major challenge. And I wonder if we can make some, like, almost like a code of practice or some best practices for network operators for how we can enhance the privacy of our users, and what we could do there.
Yeah.
More on the operator side than the client side. But yeah, thanks for an interesting presentation.
Sure.
Hi there, Neil McRae from BT Piers. Thanks, that was a really good presentation. The one question I had was, have you actually looked at the kind of performance implications of doing this? So you just mentioned battery life. If I think about it, so we run a rather small Wi-Fi, biggest in the UK with 5 million hotspots, but just rolling this change out, and actually there's quite a lot of our solutions that actually depend upon the MAC address, otherwise you have to keep logging in. So I just wonder, ease of operation, and although we do tell people that's what we do, but ease of operation versus battery life versus processing power, have you done any research on that?
Haven't done a lot of that, but no. I mean, but the thing, typically, a lot of the, say, the Wi-Fi access points that are in consumer places like sort of coffee shops and stuff, they've got a pretty short sort of TTL on the DHCP lease, so it times out. So in a way, it's not typically, probably not clogging up a lot of these things, and it also depends on how it's done. With the Microsoft way, once you go beyond the probing stuff, it doesn't really have much of an impact on any kind of logging system, because I don't think many things log kind of Wi-Fi probes. The next step to go to the sort of the actual connection, you randomize Microsoft. They randomize it until you connect, and then they cache it along with the cached SSID association. So then it doesn't change. So then it probably wouldn't affect the behavior of the say authentication things. But it depends how. Also, I mean, some of the other things. I think some of the things like the tube Wi-Fi, I'm not sure whether some of that uses MAC address sort of tie-ins. I mean, there is also the EAP-SIM based approaches being introduced now on the underground, which speed things up, and that's kind of independent, as far as I can see, from the MAC address. It shouldn't necessarily matter what you're using, as long as you've got the right SIM card in the device.
And then one follow-up question. We have a lot of big Wi-Fi deployments in enterprises. With you got 5,000 users where they're moving around the building, and increasingly and irritatingly, they're not even putting an Ethernet cable anymore. It's just Wi-Fi everywhere. I just wonder if anyone's looked at what the impact of those sort of setups would be, because frankly, it's a pain in the ass to run it as it is, let alone this sort of. It has a great use case. It's just what does the impact for the user mean, and how does that? Are we making sure that those things still work, or that we're not breaking things that all of a sudden large enterprise rolls out Windows 10 and their Wi-Fi falls over?
I think with sort of like when you're doing enterprise deployments and you're deploying it in a company or something, and you don't want that kind of overhead, or you kind of don't really need it, then you probably just provision all the machines that are on the network. I don't know. I'm not sure what happens with this sort of bring your own device type thing, but you can still probably provision them to essentially maybe not use it if that's the company policy, and I guess you can then put that in a way. It doesn't really make sense to randomize if it's sort of entirely managed network. I think it's more of an issue where you don't necessarily want to be tracked. There's no reason why you should be tracked when you go into, say, a Costa Coffee or something, or the airport. So, but I think you've got a big enterprise. You want to manage your users and your devices, so you should be able to switch it off.
Okay, thanks.
Okay. If we can just do it quickly, one question from Ivan here, and the last one.
Hi, Ivan Beveridge, Live Journal. Are there any issues with regards to MAC address clashes?
Yeah, well, it can potentially be an issue. Typically, the OSs do flash up a kind of warning if they detect a clash, but
does it sort of probe, find there's a clash, and retry a different MAC address or anything like that?
Well, it hadn't actually happened that much, but I haven't actually looked at the exact approaches that are used. Yeah, but traditionally, some of them used to just sort of say someone else is using your IP address or your MAC address, then it can disable the network. But sometimes it'll say retry. But I'm not exactly sure. Yeah, it is potentially an issue, but it's still fairly wide space if you randomize in the whole thing apart from the admin bit. But it's still a possibility. Yeah.
Okay. Thank you.
Sure.
Okay. Thank you very much, Piers.
Sure. Right.